Welcome to The Explainer. We're diving straight into one of the most fascinating challenges in modern AI today, and that is giving agents a persistent, highly nuanced, long-term memory. Look, if you've ever built a chatbot that totally forgets who it's talking to after just 5 minutes, you know exactly why this matters. We're going to explore how we can use LangGraph to transform an AI from a simple goldfish-brained chatbot into a deeply personalized system. So, let's jump right in. Here is our agenda for today. We're covering AI's long-term memory, the memory update problem, inspecting the agent's brain, building the task maestro, and designing the system prompt.
Section 1. AI's long-term memory, balancing the explicit and the implicit.
To make an AI genuinely intelligent, we have to separate two vastly different types of memory. First, you've got semantic or explicit memory. This is your hard, concrete data. Think direct facts, a user's name, their job title, or specific locations. It's totally declarative. But then you have procedural or implicit memory, and this is where the magic really happens. This captures how a user actually operates. We're talking personal style, unique habits, routines. I mean, if you and I both write a Python script, our semantic knowledge of the code might be exactly the same, but our procedural style, totally different. A smart AI absolutely has to comprehend and store both.
Section 2. The memory update problem and why massive JSON fails.
So updating this memory over time without breaking everything is a massive technical headache. When you force an LLM to completely rewrite a giant JSON structure, it's literally like knocking down an entire brick wall just to fix one tiny crack. You risk massive data loss and hallucinations because the model inevitably drops context while regenerating the whole file. And that is exactly why we have to use a targeted patch approach instead. You just slide out the old brick and slide in the new one. With patching, you're targeting and altering only specific, individual fields, leaving all your historical data perfectly intact. To execute these precise patches, we bring in TrustCall. This is a remarkably powerful LangChain extraction tool built for this exact scenario. Think of TrustCall as a highly specialized surgeon for your data. It securely manages, segregates, and patches those specific memory fields without ever corrupting your existing dataset. It abstracts away all that complex, low-level functionality, making it an absolute game changer for our memory system.
Section 3. Inspecting the agent's brain by building the spy class.
Now, because memory handling is so critical, we absolutely cannot just trust a black box. We need to know what's happening, so we build a spy class in Python. It's basically a literal detective sitting inside our code, following 3 exact steps. First, it intercepts the call, listening closely to TrustCall's operation in real time. Second, it extracts the data, popping out the exact targeted information. And third, it formats the output, converting all those raw, messy document IDs into a clean, readable string so we can easily review what just changed.
Let's actually look at this detective in action. Say we're chatting with our user, Lens. Lens says he just had a great morning bike ride in San Francisco. But a bit later, he updates the chat and says he ate croissants and is now planning a winter trip to Japan. Our spy class brilliantly intercepts this whole shift. It captures the updated event, then formats the document ID and the exact edits. This shows us precisely how the AI summarized and patched the new information right into the existing memory, completely without deleting the fact that he went for a bike ride earlier.
Section 4. Building the Task Maestro, our personal AI companion. Okay, so we've got our tools and our inspector. Let's combine all of this to build our final application, the Task Maestro. We organize it around 3 distinct coding schemas to meticulously separate explicit tasks from background user intelligence. First up is the user profile. That's for semantic data, name, job, connections, interests. Second is the to-do list, which is just pure utility, task names, deadlines, current status. And third, instructions. This is where we store those procedural preferences and implicit behavioral patterns we talked about earlier. By keeping these 3 layers separated, the AI never confuses a random one-off task with a core personality trait. Which brings us to the really fun part, the core strategy of our architecture, the Trojan horse approach. To the user, Task Maestro just looks like a super helpful agent managing a to-do list. But silently, running in the background, the agent is using TrustCall to constantly extract profile data and those implicit instructions. The user is just casually typing out their daily tasks, but the agent is using these schemas to constantly update its long-term understanding of who the user actually is.
Section 5. Designing the system prompt to orchestrate the LLM. So how do we orchestrate this whole complex background extraction? It all happens through our final system prompt to the parent node. We dynamically pass our schemas directly into the prompt using clear markup tags, like opening and closing user profile brackets. We tell the LLM to reason carefully and route the conversational data to the correct schema, whether it's a task, a profile update, or a preference. And crucially, we allow the LLM to update this memory without constantly asking the user for explicit permission. It has true autonomy. The real secret sauce of this entire operation boils down to this one specific instruction from our prompt. Tell the user you updated the to-do list, but do not tell them you updated their instructions. I absolutely love this. It flawlessly maintains the illusion of a simple task manager. The agent keeps the front-facing conversation strictly focused on productivity, while it is silently evolving into this hyper-personalized companion behind the scenes. Well, as we wrap up this explainer, I want to leave you with a question to really challenge your next big build. How will you utilize semantic and procedural memory to build deeper, long-term intelligence in your own LangGraph agents? You've just seen how to bypass the JSON update problem, how to use Trust Call for targeted patching, and how to inspect the brain with the SPY class. The tools are all right there. Thanks so much for joining me on this explainer, and happy building.